So let's go ahead. And then a car travel 200 miles east in the 4 hours, and then 300 miles west in equal the total distance divided by the total time. So what the total distance in this problem? The car traveled 2 miles east, and then it went to 300 miles west. So travel a total distance of 500 miles, and then total times is 4 hours plus 5 hours. So that 9 hours. So all we got to do is take 500 and divide by 9. So average is 55.6 or 0.5 repeating miles per hour. So that the answer is real to answer choice D number 2. Cars travel 2 miles east. Average velocity in 4 hours and then 300 miles with 5 hours. Suppose what is the velocity of the car for this entire? So how is this problem different from the last problem? How can we calculate the average velocity of the car? The average velocity is equal to the displacement divided by the total time as opposed to the total distance covered total time. So what is the displacement of the vehicles? We know it traveled 200 miles east and then traveled 300 miles west, and you to understand that distance is a scalar quantity. It can only be positive. Distance is a vector. Can be positive or negative. So the displacement for this first part of trip is positive 200 because it was going in the positive x direction, and then going west is negative 200. So if we added these two values, the net displacement to enter is negative 100 miles because we start here. And the net result, if you look at the initial positive, the final position, the cars travel 100 miles west. Now the total time is still 9 hours, so it is going to negative 100 divided by 9, and so this is going to be negative 11.1 miles. So keep this in mind. The speed is always positive. Velocity can be positive or negative. Velocity is a vector. It has magnitude and direction, but the speed is scalar quantity, has magnitude only. So D is the right answer, number 3. Car. Car accelerated from 5 meters per second to 45 meters per second. How far does the car travel during the time period? Now, if for these types of problem, you may want to make a list of what you know and what you need. So we giving the initial speed as 15 meters per second. We have the final speed, meter per second. Meter per second, and then time period is 9 seconds. Our goal is to find the distance that the car travel, or the displacement. Distance and displacement is the same whenever the car travel in one direction, if does not change direction. The equation that we need that holds all of these variables is that when it is 1/2 of initial plus v final multiplied by t. So you can only use this equation if the car is moving with the constant acceleration. It can't be moving with the constant speed, so it is going to be 1/2 the initial speed plus the final speed multiplied by the time. 15 plus 45 is 60, and 60 divided by 2 give us an average speed of 30 meters per second. 30 is the average speed between 15 and 45. So it is going to be 30 times 9.3 times 9 is 27. So 39 is 270, and it is 270 meters, which means C is the right answer. Number 4, files of which of the following statement is not the concerning projectile motion that was kicked horizontally off 200 meter oak cliff and initial. Second, so go ahead and try this problem. So let's begin following the trajectory. So the initial speed is 15 meter per second, and the height of the cliff is 200 meter. So 200 meters. So which of the following statement is not true? So let's start with the initial velocity, vertical velocity is that zero. The point the pole is moving the x direction, it is not moving at an angle, it has no y. Components, so whenever an object is moving horizontally, the vertical speed is always zero. The only way the vertical speed will not be zero is it is moving the angle, it is moving straight up anything, but horizontal motion, so anytime it's horizontal, v is zero, velocity y is zero. So that statement now, what b e, the horizontal speed, is that true or false? And what about b, the horizontal acceleration is negative 9 meter per second square. Now whenever you have object that moving is projectile motion, by definition the only force acting the object gravity, so there no air resistance, nothing. Also the entire gravity only act in y direction. So we have vertical acceleration of negative 9.8 due to the gravity. Since gravity is the only force acting with the object is projectile motion, by definition there is no horizontal acceleration, it has to be zero, which means b. If the false statement is the horizontal acceleration is not negative 9.3, that is vertical acceleration, that's as yx is the horizontal acceleration. Now E is the true statement, because if the horizontal acceleration is zero, then the velocity Vx is constant, which means the horizontal speed is constant as well. Now, since Vx is a constant, that means C has to be true statement. So let's call this point P and point 3, because Vx is constant everywhere along this trajectory. Horizontal speed will be 15 meters per second. That not going to change anything to acceleration is zero. The velocity will be constant, and so horizontal speed always 15 meters per second everywhere along this curve. Now that about d is also true statement. Notice that the vertical acceleration is negative 9.8 meter per second squared. The acceleration tells you how much the velocity changes every second. So because y is negative 9.8, that means that the vertical velocity will change by 9 meter per second every second. The negative sign tells us that the velocity will be decreased by 9.8 meter per second every second. Now, on the other hand, ax is zero, which means that velocity in the x direction does not change, which explains why vx is constant. So therefore, the only statement that is true is not true. The statement b is horizontal state is not negative 9.8, is zero. Projectile motion, so make sure you keep this in mind. For projectile motion, ax is always zero, y is negative 9.8 always, vx will always be constant, and vy is zero. Let's say if you are going this direction, at this point vy zero, anytime you have an object moving in x direction, vy zero. So if you get projectile that looks like this, at the very top, the vertical speed is zero because it is moving horizontally at the point. And keep in mind that vy change by 9.8 meter per second every second. So if you're dealing with the velocity, the vertical velocity always decrease by 9.8 meter per second every second. Number 5, ball is released from rest at top of 4 150 meter cliff. How long would take the pole to hit the ground? So let's start with the picture. The cliff and here the ground, so the 450-meter high. So here the pole, now it is released from rest, which means that the initial speed in the y directed is zero. How long will it take for it to hit the ground? What equation should we use? We can use this equation. The displacement is equal to v initial t plus 1/2 at t squared. Now we are dealing with the vertical displacement, so we need to use the initial vertical speed and its relation in the y direction. The displacement in the y direction as moved from position A to position B is negative 450 because we are going the negative phi direction. V initial in this problem is 0. And the relation in the y direction is negative 9.8. So we have is negative 450 is equal to negative 4.9 times squared. So negative 450 divided by 9.9, that is positive 91.837, and that's equal to square. How? Let's take the square root of both sides. So is 9.583 second, which means E is the answer number 6. Pole drawn with an initial is based of 25 meter per second from the top of 500-meter building. How long will it take the pole to hit the ground? So in this problem, we have the same picture, but the time. But this time, the pole is drawn down with the initial vertical speed of 25 meters per second, and the height of the building is a little bit different. It is 500 meters this time. However, we could use the same formula to calculate the time. So the vertical displacement going to be equal to the initial speed multiplied by the time plus of half at t square. Now the displacement in the y direction, we can move from position A to position B, is still negative to negative 500 in this example, and the velocity in y direction is negative, so will be called the pole moving the negative direction. So the going negative 25 times t and negative 9.5, that is negative 4.9. So positive and negative, so sign will be negative sign. So this is the expressions that we have quadratic expression or quadratic equation. So we need to use the quadratic formula to solve for t. So let's take everything from the right side and move it to the left side. So this is going to be 4.9 t squared plus 25 times minus 500, and that equals 0. Now let's use the formula. T is equal the negative plus or minus the square root of p square minus 4 of p square minus or p square minus 4ac all divided by 2a. So in this problem is a 4.9, p is 25 and c is negative. So this is going to be 25 plus minus the square root of 25 minus 4 times a times c divided by 2a, which is 2 times 4.9. Now I am going to do this step by step, so you will not make any mistakes. 25 quadratic is 625 negative 4 times 4.9 times negative 500. That's a positive 9,800, and 2 times 4.9 is 9.8. So that let's add it 625 plus 9,800. So now that we now have negative 25 plus or minus the square root of 20.